find an equation of the tangent line to the curve y equals sine of 2x plus sine squared of 2x at the point 0, 0. Now, we need a tangent line, so for the slope of that, we're going to need the derivative. So we're going to need y prime. Let's take a look here. We're going to use the chain rule for each of these. The first one, we just need the chain rule once. The derivative of sine of u is cosine of u. So we're going to have cosine of 2x times the derivative of the inside. The derivative of 2x is 2. I'm just going to stick that 2 out front for now. I know I keep putting the coefficients at the end and then rewriting it and bringing them to the front. We can just bring them to the front earlier on if we are really comfortable with the way the chain rule works. So then we have plus the derivative of the second term, and this is going to be more involved because the outermost function is the squared function, and then the middle function is sine, and then the inner function is 2x. So let's see if we can do this. The derivative of v squared is 2v, so that's going to give us 2 times sine of 2x, times the derivative of the middle function. The derivative of sine of u is cosine of u, so that's going to be cosine of 2x, times the derivative of the innermost function. The derivative of 2x is 2, and the funny thing is here, I can't just move this 2 out front, because there's already a 2 there. We're going to have to multiply them either way. 2 times 2 is 4. So I haven't actually saved us any work anyways, but let's write this out. 2 cosine of 2x plus 4 sine of 2x cosine of 2x. That is the derivative, but we need to know the derivative when x equals 0, because that's going to give us the slope of the tangent line at that point. So we want y prime at 0. When we do that, we're going to have to evaluate cosine of 0 and sine of 0. So we've got 2 cosine of 0, 2 times 0, 0, plus 4 sine of 0 cosine of 0. Now we know that cosine of 0 is 1 and sine of 0 is 0. So that means the second term is going to be 0, because 0 times anything is 0. But the first term is going to be 2 times 1, which is 2. So this derivative is going to be 2, which means the slope is 2. And we could use point slope form, because we've got the point and we've got the slope. But we actually can do a little bit less work than that. We know that this line goes through the origin and has slope 2. What's the equation of the line that goes through the origin and has slope 2? Well, that's just going to be y equals 2x. 2x plus 0, because the x-intercept is the origin, which is 0. So this is the equation of the tangent line. Let me just show you quickly a graph of the original function and of this tangent line. All right, here we go. You can see the sine of 2x plus sine squared of 2x is kind of a gnarly curve. I really like that. Almost looks like a heartbeat. I don't actually know what that machine is called, but I think you know what I mean. And then we've got our tangent line, y equals 2x. It is tangent at the origin. It does cross over the curve later. I mean, it's perfectly possible for a tangent line to then cross the function somewhere later. I know sometimes students get befuddled by that, but if we were to zoom in, and I can't actually zoom in much here because this is just a screenshot of the graph, but if you were to zoom in, you would see that these two are tangent to each other at the origin.